4 guests in the room with us today. Super excited. This has never happened before. We're going to be talking about the R&D shop, makers and shapers of ERDC's research. I have with me Hayden Skipper. He is a model maker. Chris Abels, tool maker supervisor. Tim Hynum, he is a welding shop supervisor. And Zach Smith, program manager of R&D fabrication group at the Research and Development Shop with the Installation Operations Command. Good morning, gentlemen.
Good morning.
Good morning.
How y'all doing this morning?
Well.
All right, so we're going to start off pretty easy because people are going to learn about you guys. Tell me about yourselves and your backgrounds.
Yes, my name is Zach Smith. I moved here in 1994. I went to Vicksburg High School for my senior year. Graduated and then went to work with Gray Plumbing.
Okay.
Mr. Gary put me through plumbing school 4 years, and then after that I continued my career with him for 2 years, and then we ended up getting a position in a welding shop here at ERDC, and from there it's just my career field has expanded.
Awesome. Awesome. Well, great. And so, Hayden?
Hey, Hayden Skipper, lived in Vicksburg my whole life, went to Warren Central High School, graduated 2010, done a little bit of everything, started in the model shop in 2015, and been there ever since.
Okay. Chris?
I'm Chris Abels. I graduated from Warren Central in 2002, and then I went to Hines, machine shop school at Hines, and pretty much right out of school went to work at ERDC in 2006 and been there ever since.
Awesome. Timmy?
Timmy Hynum, supervisor of the weld shop. I've pretty much been here in Vicksburg all my life, graduated from Vicksburg High School in '95 and started doing steel work and welding then, so I've had probably 30 years or more welding experience and traveled a lot of places and worked a bunch of diverse, different places and things, oil rigs, shipyards, chemical plants, oil refineries, just a multitude of different things to see and experience.
Awesome. Well, with everybody's experience, you guys joined together probably is a pretty powerful team. So we're going to understand how powerful that is. So what are your roles at ERDC?
My roles at ERDC, this is Zach, by the way.
Okay. I think it'd be easy, I think, if everybody, before they talk, say who they are so people can know who they're talking to.
My roles at ERDC are more or less to keep the shops in function.
Okay.
Keep everybody more or less happy, keep equipment running, supply materials and such.
This is Hayden. My roles at ERDC are to support the different labs with various projects they bring in. We do a lot of acrylic work, build physical models for CHL, GSL, EL, just to keep everybody, anything and everything we can do and keep them going.
Okay, sounds good.
This is Chris. I just keep the day-to-day operations going in the machine shop. Just keep all the researchers going. Keep just about it.
Okay.
This is Timmy, pretty much the same thing. Just keep business going as it is. There's a lot to explain about what we do in our everyday roles. I really don't know where to start.
Well, we're gonna dive into that. So usually, we've had guests from the laboratories on the show, but y'all are a little different. And so tell us a little bit more about the R&D shop and how do you support ERDC as a whole?
So our mission at ERDC is to provide the engineers and scientists and the warfighter with a unique and specialized skill set to design, fabricate, and assemble prototype and scale models. Also research components that are used for testing to validate the research products.
So that's a lot.
Mm-hmm.
That's a lot. Anybody want to add anything to that? No, we're good. Okay. So often when people think of ERDC, they think of engineers and scientists, but our organization is home to many more careers than those. The R&D shop is a perfect example of this. What kind of skill sets and jobs do you utilize? All right, y'all don't jump in all at once now.
In the machine shop, we got, our skill set is pretty broad. We CNC machines, CAD CAM software, manual machines, pretty design, fabrication, pretty much everything. We pretty much do anything.
A lot of multi-craft.
Yeah, we're pretty much asked to do anything, and we figure it out.
Well, with technology changing, I'm sure with new equipment and stuff like that, that's always helpful to make your job a little bit more, I guess, easier, maybe?
Yeah, it is. Technology is helping. It's a lot
Okay.
faster. We can produce parts a whole lot faster, a lot
Okay.
more precise. So,
Right.
Yeah,
Right.
CNC is pretty much taking the world over these days.
CNC, what is that?
Computer numerical control.
Okay.
It's computerized machines that pretty much do the work for you. You
Okay.
don't have to like manually machine or do anything. It's computer programmed.
you just,
Right.
We write the program it, put it in the machine, set everything up, set the tools up, and just start running.
Start the process.
Start the process.
Okay. Anybody like to add anything to that?
So, like in the model shop, we, you think of just engineers coming down and say, hey, do this. We have to, like Chris was saying, we have to use CNC to machine everything. You got to write programs. It's a lot of learning involved, but there's not much that we can't do to support the labs.
Well, that's good to hear. That's good to hear. So, throughout your career so far, what has been the most interesting project that you've supported through the shop?
Multiple.
It's
Yeah.
multiple. I mean,
Come on, let's dive into it.
we've had projects from all labs, and I think one that stands out for me, I went with GSL out to Dugway, Utah, and got to watch a lot of stuff get blown up.
Okay.
So that was interesting.
Just a lot of the locks and dam models and stuff, they're always interesting, different ways. Some of them are for fish passages, some of them are,
Tow traffic,
erosion, just a variety of stuff.
So I understand, don't they come to you sometimes with a napkin and have something drawn out and you guys got to...
Oh, yes.
Very
How,
much
how
so.
often does that happen?
All the time.
And regularly, 3 to 4 times a day.
Well, the cool thing about it is y'all make it come to life, right?
Right.
Okay.
Right.
Yeah, we're a lot of times a bridge between the engineers and the actual work happening. Because a lot of your engineers don't really, they know how to do their testing and their research, but they may not know how to construct certain things. So that's where we bridge the gap between the engineers and the actual construction going
Right.
on.
But how often do you come to them and go, man, we can't do that?
It happens.
But you don't want to say you can't do something. You want to prove that you can't do it. You want to strive to make it happen, right?
Yeah.
We don't like to say we can't do anything.
Right.
Yeah, we can pretty much do everything, but some processes we may not be able to do. We know other people or shops who can do that, and we'll outsource stuff every once in a while just because we may not have that one capability.
Right.
Sometimes you're limited to the machine capability too of
Right.
certain aspects of the job.
The limitations, right. What kinds of challenges do you face in your jobs, and how do you overcome those challenges?
I really think that's what makes our job unique, is the challenges.
Every day is something different.
Yeah. I mean, it's,
Getting material,
Okay.
locating different things. Just, it's daily.
And y'all do things with all the labs, right? I mean, even the
We do.
ones from
Yeah.
Champaign and all that. So
We do.
Yeah, Champagne and Searle and Trail.
okay.
yeah.
Okay.
It's always nice knowing that you've got a support group around with all the different shops. You can always, if you can't figure it out, somebody may can.
Right. Right.
Or may have a different idea, a different approach to it, and you can combine your two ideas and get the job done, complete the mission.
So how many people are in the R&D shop?
I think we're right at 27 right now.
So is that typical, or do you normally have more than that, or is that
We had less than that.
Oh, really?
We're expanding.
because the projects are probably expanding too, right?
Yes, ma'am.
So I mean, sometimes I guess emergencies come up.
Mhm.
Okay, so you just got to roll your sleeves up and
Get
just make it
after it.
happen. Okay.
Yes, ma'am.
So ERDC also is home to some incredibly unique facilities. Can you tell us about any specialized equipment or capabilities that the R&D shop has?
We've got various 3D printers and 5-axis CNC routers, water jets. And the equipment's there.
So, I mean, I guess, how often is the 3D printer, how often is that utilized?
It's
Pretty regular.
yeah.
Really? So what's some cool things that are made with that you guys utilize?
I mean, you can print draft tubes, baffle blocks for spillways, and just a multitude of stuff.
Okay.
Sometimes you may need a spacer for something. You can print that, or a little
Sheen
fillet or yeah.
Okay. Okay. Anything else y'all would like to add?
The machine shop's got 5-axis mills, multiple CNC lathes, got a new one on order because everything we have they try to max out the capacity of, so
Right.
we got to go bigger. CNC mills, manuals, we still have manual stuff, so we got a little bit of everything.
Okay.
And the welding shop has pretty much all your basic equipment for metal fabrication. We got a CNC plasma table, which is the heart of the shop. It's where most of our parts come from. And we also have a fleet of rig trucks to service on the road. We do work in the shop, and when we build a project and it goes to the field for testing, we'll follow it to the field and go work on it in the field. We've been all over the United States, following projects around. It's been pretty fun.
Well, and I bet it's very rewarding to see something in action, like once you've made it, modeled it, and things like that, to see it in action and the success that it brings to their projects and stuff like that. So I would imagine there's a lot of creativity involved with this job. What does the process look like when a researcher comes to you with a project? How do you communicate and collaborate to design and fabricate the parts that you need?
I know in the model shop, start out on a piece of paper. And then from there, it'll go to CAD drawings. And then you get to Hayden, and they have to initiate taking those drawings apart in order to create those files and parts. So, and then from there, it goes to the machine.
You have to really figure out what can physically work and what can't.
Right.
Just because you can draw it doesn't mean that you can, put it together that way like a puzzle. And
Right.
It's basically a puzzle. You have to break it apart, cut it out, put it back together.
A lot of head scratching.
Mm-hmm.
Okay.
We don't have the 7-year degree, but we do engineer a lot.
A lot of engineering comes in along the way.
Right, right.
Yeah, we do tons of design work.
Yeah.
Like you said, they bring it to us on a napkin and
Yeah.
then tell us what they want, and then we tell them what they really want, and then that's what we make for them.
They don't know what they want till you let them know.
Yeah, we let them know what they need and go from there.
Of course, we do prefer blueprints or CAD drawings, but it doesn't always happen that way.
Okay, guys, I understand in 2021, the U.S. Army Corps of Engineers met the challenge to provide additional hospital rooms for COVID patients by inventing portable medical units at ERDC. These units were to relieve overcrowded hospital facilities. These prefabricated containers were modified as medical isolation rooms, which were airborne infectious disease isolation units. The invention was for a quick and low-cost method of building airborne infectious isolation rooms using existing commercially available intermodal container units. The production challenges issued by USACE focused on quick fabrication and evaluation of the units, nationwide availabilities of all materials, labor skill sets, and procurement options, use of fire-resistant materials, compliance with life, health, and safety codes, and the important medical requirements of negative pressure, direct line-of-sight patient visibility, clean and disinfectant access, and hookups for emergency backup power. I understand you guys made a remarkable turnaround on the invention. With nonstop intensity, you guys fabricated a unit that met USACE requirements in less than 24 hours using locally produced materials with the required budget. Your team then provided USACE with a detailed design document, including general cost estimates on how to construct these units and transition the technology nationwide. The team conquered the USACE mission to build or repurpose COVID-19 facilities, fulfilling the urgency of patients in U.S. hotspots in need of more hospital space. Can you tell me any about that project?
We were just tasked with, I think it was
Was that a drawing on a napkin?
more or less.
Okay.
And word of mouth.
Okay.
I think it was just, that all happened so fast, man. All that happened so fast. I mean, it was just like, we need you to build this, and then everybody come together. I think there was, 4 craftsmen in each shop, and then it was.
And everybody put their heads together and
We all went at it and come up with ideas on creating how to make this thing a negative pressure pod.
Negative pressure. Tell everybody if they don't understand.
Kind of more or less keeping, I guess, bacteria and
bacteria and viruses contained within the room itself.
Okay. Well, that's great that you guys were heavily involved in that. What are some of the advantages and disadvantages of using custom-made parts or components from the R&D shop compared to the off-the-shelf products?
we don't do change orders. So if something's not right, I mean, we can hit the drawing board again and just build another one.
Okay.
So
A lot of the stuff they come to that they want, you can't go to the hardware store and buy it.
No.
Right.
So it's
It's a
custom,
unique ERDC product.
That's
right.
it.
Okay.
And you get one shot at it. If that's not what you want, then we have to back up and do it again.
Okay.
So.
Okay. Anything you guys would like to add? That's basically it.
Yeah.
So, okay, these parts and these different components that you make, how do you test and evaluate the performance and the reliability of the parts or components that are made by the shop?
I know for the welding shop, our majority of the stuff we build is tested by destructive testing. So there's usually nothing left of it when they get through testing it.
So all that hard work just disappears.
Yeah, in a millisecond.
Oh, wow. That would hurt my heart a little bit. So.
Yeah, there's not much around for us to show off that we've built before because it's destructive testing.
Okay,
Now,
right.
every once in a while, we'll get to build some lab equipment or something like that we can ooh and ah at.
Right,
But,
right.
if we're not building something for them to tear up, then we're building a structure that's used to tear something else up.
Oh, okay, good.
And a lot of the stuff the machine shop makes is what tears up the welding shop stuff. They usually throw our parts in the ocean or blow it up.
Okay,
Or it's be some kind of gauge mounts or something that has to try to survive a blast. So
right. And that's for military.
Yeah, that's
Right.
military side.
yeah, we do a lot of military work. We don't do as much civil work as the model shop does.
Okay.
We do some, but not as much.
Okay. Anything you guys like that?
So with the model shop, a lot of our nav models for rivers and locks and dams do a lot of tow traffic, and if we build guard walls and whatnot, you can physically see how they work. Gates on spillways, you can see how the water flows. Any of that stuff. If you need to make a modification, you can physically see it right there. You can make the modification.
Okay. That's helpful, right?
Yeah.
Okay. So, I already asked that. How do you test the product? So, can you tell us about any current or future projects that you are working on that will require the support of many people on the team?
Pretty much all of them.
Everybody come together. Let's work on this project.
Yes.
Okay.
I think we have the McNary project. There's Pollock. What else we got?
Garrison
Dam.
Detroit.
Yeah.
All of those are taken.
Sulak, I think.
So all hands on deck, pretty much.
Yes.
Okay.
And that's just for model shop right now. I don't really know what.
Yeah, well, welding shop and the machine shop usually work together a lot because those two trades kind of go hand in hand. So
Yeah.
we're usually helping each other out on a lot of stuff. It's
Kind of hard to go into detail about what they do.
Oh, yeah.
So, you know.
yeah, there's a lot of stuff
Yeah, we
not
can-
sure we can talk about.
That's true. That's true. So we come down to the last question, and I need each one of you guys to answer for me. What would you like the listeners to learn from this valuable conversation?
That we're your one-stop shop.
There you go.
I mean, we do it all.
Okay.
Basically, what Zach said, we can accomplish any mission that needs to be accomplished more than likely, and just know that whether you bring it in on a napkin or a drawing, we can most of the time get it done, and hard work pays off.
Awesome. Awesome.
It's kind of like they said, if you need it and we can't do it, we pretty much know somebody who can. So
You're going to call somebody.
We can take care of anything. So.
Okay.
It's a one-stop shop. Main thing, some of the people on station or campus, whatever you want to call it, would need to know is that, we're there to service them. And it's a lot easier to come to us for any work that they need done than it is to go other routes.
Right.
Outsourcing, contracting, whatever. We're there to service, the labs.
Right. Right.
So don't be scared to come see us.
Okay. Okay. Well, would y'all like to add anything else to our conversation?
Come see us.